Everyone, and welcome to the Happy Math Hour presented by the Tejano Virtual Events. This is your weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it at a later time, and also for those who may have missed today's presentation, may be able to watch it at a more convenient time. Thank you, and at this time, please mute your mics for the best sound experience. We don't want the feedback interfering with any of today's important lesson. Without further ado, here is Mr. Ruben Carrizales.
Good morning, everyone, and again, thank you for joining us for our Friday Happy Math Hour. So for today's session, we will be going over linear and nonlinear systems of equations. Okay, I believe there'll be a session for your Math 1324. So if you're here for Math 1324, there might be a link on your chat. Okay, so let's go ahead and get started. Oh, there it is. So if you're here for the Math 1324, just click on the link. Okay. For the rest of you who are here for Math 1314, let's proceed. Um, so again, this is our definition for linear systems. So a linear system is um, we're going to be dealing with equations that are lines, right? So these are our straight lines, okay? And if we see here, we show our general form of our equation, ax plus by equals to c. Now, what does linear system mean? Well, what we're going to be doing is we're going to be dealing with more than one line at a time, okay? So what we'll be doing is we'll be graphing multiple lines on one rectangular coordinate system. But what we want to find on these linear systems is to find a solution. And basically what the solution is where the lines intersect. And where these lines intersect, we're going to find an ordered pair that satisfies both equations. And again, if these lines intersect, means that they share these x and y values. So we will be also with a solution set, which will be a set of ordered pairs that satisfy both equations. It will just won't be one unique solution. We'll have several solutions. Okay. So a system can be defined as a linear equations or a system with nonlinear equations. And as you might no, a linear equation system is just made of lines. A nonlinear equation system could possibly have a line in there, but not only will we also looking at graphs of lines, but it could be a parabola or a circle. So that's what nonlinear equation stands for. So there are three ways to find solutions for systems. Okay, the three ways are the substitution method, elimination by addition method, and by graphing. Okay, and they all serve their purpose, but let's study all three of them and let's try to master all three. Okay, so again, the solution is the intersection of these graphs, and what we're going to find where these graphs intersect, they're going to share this x and y values, okay? And that will be our solution. So here are some examples of the solutions that we might find. So for instance, on our first example here, on our first graph, okay, we are dealing with a linear system because we have a graph of two lines. And if you see here where these two lines intersect at this point to 0, okay, that would be my solution for this system. At 2, 0, um, at this point satisfies the equation for both. So if I would put x for 2 for the first one and 0 for y, this should equal 1. And if I put 2 for the x and 0 for the y on the second equation, I should get this answer as for 2. Okay. Now, if we look at the second middle graph picture, we are dealing with a nonlinear system because we do have a line. There's a graph on the line, but we also have a parabola out here. And if you see on this problem, we have a multiple solutions. We're going to have 2 points where it satisfies these two equations. Okay, so we'll have a solution set here. And then if we look at the last graph, okay, we do have a line and a parabola, but these two graphs never intersect. So on this particular one, again, on the first one I had my solution was 2, 0. And then on my middle one, I have two solutions. I had at 0, -1, and 2 and 1. But for the last one, there is no solution because these two graphs do not intersect. Okay? So um, before we get started on the methods for solving um, systems of equations, um, let's start by determining whether the answer is a solution for our system. Okay, so this is a homework problem, and it says determine whether each ordered pair is a solution of the system. So what they want me to do to verify that this point 0, -4 for A is a solution of the system, I'm going to replace x and y with this point, and it has to give me a true statement. Now, this statement has to be true for both of these equations. On this particular problem, I only have two lines, right? So I have to have a true statement for both of the lines. If it fails any of the two lines, then there's no solution. Okay, so let's go ahead and get started. So here, for the solution for the first one, I'm going to plug in 0, -4 for the first equation, which is 2x minus y equals 4. So here we have 2 times 0 minus a -4. This should equal 4. So let's simplify. And when I simplify, I have 0 plus 4, and 0 plus 4 is 4. So 4 does equal 4. This gives me a true statement. So what this is telling me is that this point is part of this graph, of this line. It's a point that lies on that line. Okay. Now, for it to be a solution, though, of the system, it has to satisfy also the other equation. So, and if I put it on there, if I put it here for 8x plus y equals -1, I replace the x and y with the 0, -4, I see here that I do not get a true statement. -4 is not equal to a -9. So since this is a false statement, 0, -4 is not a solution of the system, because for it to be a solution, it has to satisfy all of the equations in that system. Okay, so let's go ahead and try it again. Let's do B. We'll put in the -1/2, -5 for the first equation. Okay, I see that it does give me a true statement to have 4 is equal to 4. And I'm going to do it again. I'm going to plug in this point to that second equation. And when I plug it into the second equation, I see that, oh, this one does also give me a true statement. -9 is equal to -9. So therefore, this point is a solution of the system. Okay, oops. So this point is a solution of the system. All right, so let's compare two of the methods that we can use to solve systems. So the two methods that I'm going to present to you right now is using the substitution method and the elimination method. And both the names basically tell us all on how to solve. Okay, so the first one for the substitution method, just how the name suggests, is you're going to choose one of the equations and you're going to solve for one of the variables. It does not matter the variable that you want to solve for. You can solve for x or y, it does not matter. The choice is up to you. Okay. So once you do that, and in my case, I'm going to solve for x. I'll solve for x and I'll have x is equal to 4 minus y. I move the y to the other side. That's all I did. Okay. So when I have this, um, I'm going to substitute this answer to the other equation. So my other equation was x minus y equals 2. And everywhere I see x, I'm going to substitute this 4 minus y. So we have 4 minus y equals 2. Let's simplify. And when I simplify, I have y equals 1. Yes? So, and I didn't do my work here. So for minus y is a minus 2y. Um, subtract 4 on both sides. We have minus 2y is equal to minus 2 divided by a -2 on both sides. And we have y equals 1. So now I have the y value that is associated with my solution All I need to do is now replace it to any of the two equations to get my x value. But what I'll do is I'm going to substitute it to this one right here where it has the in red. Since I already know I want to find x, I'm going to plug it in there. So when I do that, I plug in the 1 for y, and I'll have 4 minus y is going to give me the 3. Okay, so this is called the substitution method. Now, the elimination method, just like the name sounds, we want to eliminate one of the variables on the equations so, so we can have the one known. So what I'll do is just like the name says, to eliminate a variable, I'm going to add both of the equations, yes? So here, we're going to choose a variable to eliminate, and let's eliminate the y. So here, to eliminate the y, there's nothing that I need to do to either two equations. Just by simply adding these two equations, I'm going to get rid of my y. So because I said plus y minus y will give me 0. So if I do this, when I add these two equations together, x plus x is 2x, 4 plus 2 is 6. So to solve for x, I'm going to divide by 2 on both sides. So x is equal to 3. So it's the same solution that I had before. So again, to solve for my y, now that I have one of the nodes, I'm going to replace it to any other two equations. Okay, so again, I'm going to choose this time the x plus y equals 4, right? So everywhere I see y, or everywhere I see x, I'm going to plug in 3. So we have 3 plus y equals 4. To solve for y, I'm going to subtract 3 on both sides, and I get y equals 1, which is the same solution set as before. So the solution for this system is x is equal to 3, y is equal to 1. It's this order pair 3, 1. Okay. All right. So let's try it again. Solve the system of equations by using any method. Okay. Now, um, if they let us choose any method, let's try to use the um, easiest method, or the one that's basically set up for you to solve. So if I look at this system, I have 2x plus 3 equals y, and then that is in slope intercept form, right, if you recognize it. And then we have x plus 2y equals negative 4, which is our general form. But the method that I would like to use, since they're letting me use any method, I'm going to use a substitution method because they already solved for one of the variables for me. They tell me that y is equal to 2x plus 3. So it's a perfect candidate for using the substitution method. So let's go ahead and do this. Let's go ahead and use the substitution method. So since they already solved for y, I'm going to replace this value, 2x plus 3, everywhere I see y on the other equation, which is the x plus 2y equals to negative 4. So let's go ahead and do that. Okay, let's substitute, and I have x plus 2 times 2x plus 3 equals negative 4. So I'm going to simplify. The first thing I need to do is distribute this 2 to the 2x plus 3. So when I do that, again, x plus 4x plus 6 equals negative 4. I'm going to combine my like terms. X plus 4x is 5x. I'm going to move the 6 to the other side by subtracting it. So I have minus 4 minus 6. So a negative 4 with a negative 6 gives me a negative 10. To solve for x, I'm going to divide both sides by 5. So x is equal to a negative 2. So now that I have one of the variables known, I just need to get my y, and I'm going to use that red equation again. Okay, so I'm going to substitute, or it's called back substitute, the equation. So here we have 2x plus 3 is equal to y. Everywhere I see x, I'm going to plug in the negative 2. So we have 2 times the negative 2 gives me a negative 4. Negative 4 plus 3 is a negative 1. So y is equal to negative 1. And the x was the negative 2. So my solution set is negative 2, negative 1. Okay. And again, if we wanted to verify our work, we can do what we did for our first example. Replace these values to both of these equations. And when I do that, I should get a true statement for both. Okay. All right. How about this one? Solve the system of equations using any method. We have 3x minus 2y equals 7, y is equal to 2x minus 3. Okay. Again, what I see here is they've set it up for me to do my substitution method. Why is that? Because um, they solve for one of the variables for me in here. Again, this is in slope-intercept form, just so we don't forget our forms of equations. So that's the method that I'm going to use. I'm going to use the substitution method once again. Okay, so what I need to do is I'm going to substitute this value, 2x minus 3, everywhere I see y on the other equation. So we have 3x minus 2 times 2x minus 3 equals 7. Again, I'm going to distribute by simplifying. We have 3x minus 4x plus 6 equals 7. Combine my like terms. 3x minus 4x is a negative x. Subtract the 6 on both sides. I have 1. So I want to solve for x. So I don't want negative x. So I'm going to multiply by negative 1 on both sides. This is going to give me x is equal to negative 1. So then again, I'm going to use back substitution to get my y value. And again, I'm going to use the equation where it's set up for me to get that y answer. So I'm going to use the y is equal to 2x minus 3. Everywhere I see x, I'm going to plug in that negative 1. 2 times negative 1 is negative 2 minus 3. And negative 2 with minus 3 is a negative 5. So the solution set for this system is negative 1, negative 5. Okay. All right. And again, it's good to double check your work. Plug them back in. Make sure you get a true statement. Okay. All right. So let's go ahead and do this one. Solve the system equations by using any method. So we have 2x minus 7y equals 3, minus 5x plus 3y equals 7. So in this particular one, they haven't solved for, or there's no equation that has a variable solved for. So let's practice our elimination method, yes? So the first step to using the elimination method is to choose a variable to eliminate. Again, um, it doesn't matter which one you want to eliminate. Most of the time, the one when if I'm using the elimination method, the variable that I choose to eliminate is usually the variable that has opposite signs to them. That where I can just add them, they have opposite signs and equal value. Then I don't have to do anything and just add them, and they would eliminate. But like in this case, I don't have um, equal values for the same variable, and both variables have opposite signs. So in this particular one, it doesn't matter who we eliminate. So I'm just going to go ahead and eliminate the x. So if I want to eliminate the x, again, just as I said before, I need to have the same value but opposite signs. Now, I can choose any value to eliminate, but I want to be nice to myself, so I want to find the least common multiple between 2 and 5. So since these both two are prime numbers, the least common multiple between these two is just the product of each two. 2 times a negative 5 is a negative 10. So 10 is my least common multiple. So that's what I want to have for both the first equation, positive 10x, and I want a negative 10x for the second equation. So what I need to do is I'm going to multiply a 5 to the first equation to get that 10, and I'm going to multiply a 2 to the second equation to get a 10. But please be mindful. We got to be careful. We are dealing with equations. We don't want to um, unbalance our equation. So when I multiply this 5 to the first equation, I got to make sure that I multiply to the entire equation, both sides. Okay, same thing with a 2. If I multiply a 2 to this side, I got to make sure I multiply the 2 to the other side. So I make sure that I balance my equation. So let's go ahead and do this. When I multiply a 5 to my first equation was 2x minus 7y equals 3. I got to make sure that I multiply it to the whole equation. So we have 5 times 2 is 10x. 5 times a negative 7y is a negative 35y. And the 5 times 3, which is on the other side, is 15. Okay. Now let me multiply a 2 to the second equation. My second equation was this, negative 5x plus 3y equals 7. So 2 times a negative 5 is a negative 10x. 2 times 3y is a 6y. And 2 times 7 is 14, the value on the other side of the equation. So now what I need to do is I'm going to add these two equations together. Okay. So when I do this, I see that the 10x minus 10x will become 0. I just eliminated my x value. But now let me add the y portion. Minus 35y plus 6y. This is going to give me a negative 29y. And 15 plus 14 is 29. So to solve for y, I'm going to divide both sides by a negative 29. So this is going to give me y equals negative 1. So after this step, it's the same for both methods. I'm just going to use back substitution to get the x value. Okay. So I'm going to choose any of the two equations. Again, it doesn't matter which one you choose, you will get your solution. Okay, so in this case, I just chose the first one, 2x minus 7y equals to 3 to get my x value. So again, everywhere I see y, I'm going to plug it in with my known value now, the negative 1. So we have a negative 7 with a negative 1 gives me a positive 7. So I'm going to subtract 7 on both sides. This is going to give me a negative 4 on the right. So to solve for x, I'm going to divide by 2 on both sides. So x is equal to negative 2. So the solution for this system is negative 2, negative 1. And again, I used the elimination method. Okay. All right, let's do this next one. Um, they're letting us use any method we want. Okay, so in this particular one, I'm just going to use the elimination method once again. Okay, since no variable was solved, let's just practice now elimination method. So let's choose a variable to eliminate. Again, I'm just going to choose x again as our variable of choice. Okay, so on this one, it's set up really easy because again, I have a situation that I love seeing. I like to see um, a variable with a positive and a variable with a negative on the other one. And then on this particular one, all I would have to do is multiply a 2 to that first equation to make that a 4x. Yes? So that's what I'm going to do. I'm going to multiply a 2 to that first equation. So I'm going to do 2 times 2x is 4x, 2 times a negative 5 is a negative 10y, and 2 times 6 is 12. I'm going to add it to the other equation, and when I do that, I'm going to notice something. Oh no, when I 4x minus 4x, I did eliminate my x, but I ended up eliminating also my y, because minus 10y plus 10y equals 0. Now, the question that we need to say is this a true statement? The answer is no. 0 is not equal to 11. So because when I was doing my method of elimination, I ended up with a false statement where 0 is not equal to negative 11, this is telling me that this is an inconsistent system. Now, what is inconsistent system? Means that the system has no solution. That means that these two lines do not intersect. They don't share anything in common. And more than likely, these two lines are parallel lines. Okay. So let's go ahead and now do a word problem. The given amount of an annual interest earned from a total of $9,000 invested in two funds paying simple interest. Write and solve a system of equations to find the amount interest at each given rate. Okay, so we want to find um, a total amount of investment on this given value 9,000, and they're giving us two rates to invest this $9,000. Okay, so they have a rate of a 2% and a rate of 6%. Okay, and it gives us a little bit more information that says that our annual interest is $380. So to find the solution for this, okay, let's separate this into two equations. Okay, let's call the first rate A, Um, A, and for rate 2, we'll call that B. Okay, so together they add up to a total of $9,000. These two investments should add up to $9,000. So this will um, make me or allow me to get my first equation. So if I let A be investment at the 2% and B be the investment at 6%, my equation would be A plus B should equal my total investment, which is the 9,000. Now, what I can do now is apply these percentages to get my annual interest. It says that my annual interest based on these rates are 2% and 6%. So if I'm multiplying the 2%, I change that into a decimal, 0.02 times A plus the rate of the other, which is 0.06 times B, this should equal my annual interest rate based on these rates, which is $380. And then you see now we have two equations with these two variables, A and B. So let's go ahead and solve. We have now a system, and I believe the best way to solve it is let's go ahead and let's get rid of the decimal first so we can see these problems better, right? So if I want to get rid of the decimals, I'm going to multiply the second equation by 100. And when I do that, I get 2a plus 6b is equal to 38,000. Yes? Now this makes it a little bit better for us to view. So let's go ahead and use our elimination method to solve the system. So I'm going to get rid of my a or eliminate my a. So to do that, I'm going to multiply a negative 2 to that first equation. The a plus b equals 9,000. So let's do this. So when I do that, I get negative 2a minus 2b is equal to negative 18,000. I'm going to add it to the second equation. The 2a plus 6b, excuse me, 2a plus 6b equals to the 38,000. So negative 2a plus 2a is 0, got eliminated. Minus 2b plus 6b is 4b. And negative 18,000 plus 38,000 equals 20,000. Divide by 4 on both sides, so b is equal to 5,000. So I just found out what my second investment was going to give me. My B is going to give me the total of the $5,000, right? And then now to get the A, I'm going to back substitute. Okay, so I'm going to use the first equation. A plus B equals to 9,000. Everywhere I see B, I'm going to plug in the 5,000. To solve for A, I'm going to subtract 5,000 on both sides, and I get A is equal to 4,000. Okay, so this is a way to do a real world problem and use our system of equations to solve. Okay, so again, all the examples that I had done right now dealt with this first example of my graphs. I was dealing with lines, and what I was finding is where these two lines intersect. And again, if these two lines, we saw an example where we had a no solution, and what probably caused that solution is that we were dealing with two parallel lines, lines that are parallel, never intersect, and it's going to give us an inconsistent system, meaning a no solution. Okay, but now what we want to look at is let's look at nonlinear systems. Nonlinear systems are systems that may include a line, but also include either a parabola or a circle. Okay, and again, if these two graphs don't intersect, then that means there would be a no solution. Okay, all right, so let's solve this system. We have x squared minus y equals 0, and we have 4x plus y equals 0. So if we see here on this first equation, the fact that I have an exponent of 2, this is telling me that I'm dealing with a quadratic. So that first equation is not a line, and this first equation produces a parabola. Now the second equation, oh, that one is a line. This is still a linear equation. So um, because I'm dealing with the parabola and a line, we consider this a nonlinear system. So what we're going to do is let's use the elimination method to solve for this. And I want to use the elimination method because I see that just by adding these two equations together, I would eliminate my y variable. So let's go ahead and do that. Um, let's add these two equations, and we're going to eliminate now the y. So when I add the two equations, x squared minus y equals 0 with 4x plus y equals 0, I get that I have x squared plus 0 equals 0. But again, because I have a quadratic, I'm going to move all of the variables to the left, which is going to give me x squared plus 4x equals 0. So and again, I do apologize. I skipped all those steps, right? But this is my quadratic equation. So now I have several ways to solve this. Again, we have a quadratic, we can factor, we can use our quadratic equation, we can use our square root property, but in this case, let's go ahead and factor this out. So what I'm going to do is I'm going to factor out an x, and it's going to give me x times x plus 4. Use my pro, my zero property that says that when I multiply two numbers together, the only way that I can get zero is if the first one is zero or the second one is zero or both of them are zero, right? So it's easy to see that one of my solutions is zero because if x is equal to zero, zero times anything will give me zero. And if we don't see it, this x plus 4 equals 0. When will this be? Well, if we plug in a negative 4 here, I would get 0, right? So I have two solutions here. X is equal to 0 and x is equal to negative 4. So, and this should make sense, right? If I have a parabola and it's going through and it's crossing the line, it's probably going to cross at two places. So, to find the y value, I'm going to back substitute both of these two answers to any of my two equations. Now, I'm going to be nice to myself and I'm going to plug it into my linear equation, right? So, first, I'm going to plug in 0. And when I plug it into my linear equation, I have 4 times 0 plus y equals 0. And this tells me that y equals 0. So one of my solutions is when x is equal to 0, y equals to 0. Now let me use back substitution again for the negative 4. Again, back to my linear equation. 4 times negative 4 plus y equals 0. 4 times the negative 4 gives me a negative 16. Add 16 on both sides, so this tells me that y equals to 16. So my solution set for this one, I have two answers. I have at 0, 0 and at negative 4, 16. And again, what this means is that my line is crossing my parabola at two places. And these are the two places where my graph is crossing um, and giving me my solution. Okay. So let's go ahead and let's do this. A next example. I have x minus y equals minus 5, x squared minus y equals negative 6. So we see here, um, we have again a line for the first equation and a parabola or a quadratic for the second equation. So let's go ahead and use the elimination method once again. And I want to eliminate my y again. Um, so since I want to limit my y since because both of them the x have the same sign, this have the same sign, but this one has the same value to eliminate. Let's multiply a negative 1 to the first equation, and that will give me the opposite symbol, right? So a negative 1 times x is a negative x, a negative 1 times a negative y gives me a positive y, and the negative 1 times a negative 5 gives me a positive 5. I'm going to add it to that second equation. So we have x plus y equals minus 5 added to this. So you'll see that my y's cancel. Plus y minus y will be 0. Minus 5 minus 6 will be negative 11. Okay. Now, since I have a quadratic, again, I want to move everything to one side. I did show my work for this one. So um, again, and I want to do that because I am dealing with a quadratic. My highest exponent is a 2. So when I move everything to one side, I have x squared plus x plus 11 is equal to 0. Um, so since I didn't see how to factor it, I went ahead and used my quadratic equation. And when I see that I'm solving my quadratic equation, I end up with a negative underneath the radical, and that's probably why I couldn't factor it. Um, so what this is telling me that it's going to give me an imaginary number, right? We dealt with complex numbers before, but this is not this case. We need to deal with real solutions. So this for the answer for this problem will be no solution. And what this is telling me is like that picture that we have. We have a parabola with a line where the line is not crossing our parabola. Hence, we have an inconsistent system, meaning no solution. Okay. All right. Oh, let's try this one. Hopefully you all recognize what we have here. So we are given a system where we have two equations. But the first one, we have a square on the x and we have a square on the y. So what this is telling me, this first equation, I'm dealing with a circle. Now the second equation, again, the highest exponent is a 2. I am dealing with a parabola. Okay, so again, they're letting us choose any method that we want. I'm going to go ahead and use the um, elimination method again. And what I want to do now is eliminate my x. I would rather eliminate my x because that way all I need to do is multiply a negative 3 to that first equation. And when I add them, I will eliminate my x. So let's go ahead and do this. I'm going to multiply negative 3 to that first equation, which is a circle. So negative 3 times x squared is a negative 3x squared. Negative 3 times the y squared is a negative 3y squared. And the negative 3 times the positive 25 gives me the negative 75. I'm going to add it to that second equation. Okay, so we have negative 3x with a 3x squared. I know that's going to give me the 0. Um, the minus y squared minus 16y squared, these are not like terms. So I'm just going to write them out, right? So when I add these, I have negative 3y squared minus 16y, and the negative 75 plus 0 is the negative 75. Again, I'm dealing with a quadratic, so I'm going to move everything to one side. So we have negative 3y squared minus 16y plus 75 is equal to 0. Okay, again, I'm going to use my quadratic equation again to solve for my values. Okay, and then I see that I have, again, um, remember when we're doing the square root, there's a plus or minus here. So I'm going to get two solutions. Y equals negative 25 over 3 and y equals 3. Okay, so again, I'm going to test these 2 points, and I'm going to use the other equation. I'm going to use the circle, the x squared plus y squared equals 25. So let's try the first solution. I'm going to use the easy one first, the 3. Okay, so when I plug in 3 for y, I get 9. Subtract 9 on both sides, I have x squared is equal to 16. And when I take the square root of both sides, x is equal to plus or minus 4. So this particular problem also gave me the two answers already. I have when x is equal to positive 4, y is equal to 3. And when x is equal to negative 4, y is equal to 3. Yes? So I have the two solutions already, but let's test the other point just so we can be precise and complete. Let's test the other point. And again, we tested the second one for a reason, because if you see here, if I plug in the second point, everywhere I see y for negative 25 over 3, we have negative 25 over 3 squared, which gives me 625 over 9. Okay, I'm going to subtract that value on both sides. And if you see here, what we're going to have is a negative answer when I take the square root, meaning it's not a real solution or it's no solution. So I've solved for the answer for this system. The answer for this system is only that first x value that gave me already both solutions. This parabola crosses my circle at these 2 points, at 4, 3, and negative 4, 3. Oh, there's a typo here. That should be 3. Okay. All right. Let's try this one. Okay. Ooh, we have x minus y, excuse me, x times y minus 1 equals 0. And we have 3x minus 6y plus 17 equals 0. Oh, I think the best way to solve for this one, since I have this awkward xy is let's use the substitution method. Okay, so what I'm going to do is I'm going to solve for x from the first equation. So to solve for x, I'm first going to add 1 on both sides, and then I'm going to divide by y on both sides. So this is going to give me x is equal to 1 over y. I'm going to substitute this value to the other equation, to the uh, 3x minus 6y plus 17 equals 0. Okay, so we have 3 times 1 over y minus 6y plus 17 equals 0. Okay, so let's get rid of the fraction by multiplying the whole thing by y. So when I do this, I have um, 3 minus 6y squared plus 17y equals 0. Now you can see that we're dealing with the parabola that's on its side, right? Because our axis of symmetry is the x-axis. Okay, so let's go ahead and just rearrange it so it can be a little bit prettier so we can see it. So I'm going to rearrange it into how it looks like a quadratic. So we have minus 6y squared plus 17y plus 3 equals 0. Let's go ahead and use our famous quadratic equation that can solve any x-intercept. And when I do this, again, I'm going to end up with two solutions. I end up with y equals to negative 1 over 6 and y equals to 3. Okay, I'm going to do back substitution to get my other point. Okay, I'm going to start with the negative 1 over 6. So we have x times negative 1 over 6 minus 1. So we have negative x over 6 is equal to 1. And I multiply by a negative 6 on both sides. I have x is equal to negative 6. Okay, let me go ahead and do that again. Now let me use my 3. X times 3 minus 1 equals 0. Add 1 on both sides, divide by 3 on both sides. So I have x is equal to 1/3. So my solution set for this one is 2 points again. When the first point is when x was negative 6, y was negative 1 over 6. And when x was, and when x is 1/3, y is equal to 3. Okay. So this is the methods that I used to solve the linear systems was the substitution method and elimination method. Now I did mention that there was three ways to solve for systems, and you saw that when I was giving you my examples. When I graphed them, it allowed me to see when two lines, if the two graphs intersected at a certain point. Now, we that's the we like to use the graphing method just to see if we're going to get a solution, but it would be very very hard using the graphing method to determine where the two lines exactly intersect, because what if they intersected between 2 points? Like, we're going to get decimals. It would be very hard. Like, for instance, in this example, we have the x value here is a fraction, so it'd be very hard to get an exact answer if we use the graphing method. So the graphing method to solve a system is, as always, used just to see if my graph or my system is going to have a solution. That allows me to visually see if the two equations intersect. Okay, so if you're with me, again, if you want to get a copy of my presentation, again, all you need to do is click on the icon on the top of your black screen with the box and arrow. You can download a copy on of this, and I'd like to thank you. We're almost done with the semester, fellas. So please study hard and yeah, good luck in your classes.
Thank you, Mr. Carrizales, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve on our TV sessions. Please take time to fill out the survey. Before you leave, I want to share the TV sessions that we will have next. We'll be back with Happy Math Hour next week, where Math 1314 will cover basic matrix operations and using matrix operations, while Math 1324 will be covering sets. At 1 p.m. today, we will have student success. The topic today will be EPCC student clubs. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or mic. Don't forget that we are going to be off on Monday, so you guys enjoy your 3-day weekend. Have a great weekend.